And so the other particular part of a pattern that we're going to look at here is referred to as a geometric sequence. And we can recognize if a sequence is geometric by it having a common ratio. So before with an arithmetic, it had a common difference where we were adding and subtracting by the same number every single time. A geometric sequence, however, is going to have a common ratio. And all that means is it's going to be multiplying. Sorry, I wrote that pretty small. We're going to multiply by the same number. So it's not going to be going up by the same exact number. It's going to be multiplied by the same number every single time. And the next chapter we're going to get into is called exponential functions, and that's kind of what a geometric sequence kind of refers back to. This graph is going to look like a J curve, and we've actually talked about this earlier in the semester. But it's called an exponential curve, or we kind of refer to it as a J curve. So if we were to plot these points and plot these points of a sequence, this is what it would be. This is what it would look like. Okay. So again, a geometric sequence. Okay, we can recognize if a pattern of numbers is referred to as a geometric sequence if we are looking for that multiplication. Okay, to get from one number to the next, we are consistently multiplying by the same number every single time. So I've got 5 examples that I kind of want to go through with you all to see if we can kind of get the hang of this guy here. Okay, so the first one, and again, sometimes, when it's a little easier, we can kind of recognize the pattern a little bit better. So if we look at this first one, we can see that, the difference here went up by 3, but going from 6 to 12, that's not a common distance, right? That's going to go up by 6, okay? So it went up by 3, then it went up by 6, then it went up by 12, okay? So this is not an arithmetic sequence, but you maybe recognize another pattern that's going on. Maybe we can recognize that we're multiplying by 2. And it's that multiplication, right, that times 2 in between each term that allows us to say that this is a geometric sequence. And again, we should be able to extend the pattern. If we keep multiplying by 2, 24 times 2 is 48. And 48 times 2 is 96. And again, these kind of dots just mean, forever. This pattern is just going to keep reoccurring and over and over and over and over again. Okay, so we've got another example there. Okay, we go from 1 to 4 to 16. And the reason, we kind of see this nice steep J curve, right? See how subtle it kind of starts off? We only went from 1 to 4 to even 16. But look what happens when we get to the further numbers. Look how fast this is going to start taking off here. Okay, so again, maybe this is another really easy example. You should be able to see that, we're multiplying by 4. Okay, so the pattern here is times 4. And again, using that pattern or that common ratio to get from one number to the next, I'm going to use that 16 and I'm going to multiply it by 4 to get to my next number. So it looks like it's going to be a 64. And then I'm going to do the same thing again. And again, look how fast we got all the way up to 256. So remember, terms start with term 1. So term 1 here is 1, and just in 1, 2, 3, 4, just in 5 terms, we went from 1 to 256. So, this is significantly different than if we were just be adding even by 10, 1 to 11 to 21, right? So it's super fast. It's super kind of powerful here. So maybe if we can't see it right away, just like we talked about with arithmetic, there is a kind of a mathematical approach to be able to find this. And very similar to what we did before, take 2 consecutive numbers here. So I'm just going to grab the first 2. And where before we were finding a common difference, right? We needed to find this, remember, difference means subtraction of mass, so we needed to subtract the numbers. Now we're finding a ratio, okay? A ratio is a fraction, or kind of multiplication is referred to. So I'm going to take that second number, and I'm going to divide it by the first number. Okay, so before with arithmetic, we took that second number and subtracted by the first. Okay, here we're going to divide so we can find that ratio, right? This fraction here. So 4 over 1 definitely simplifies to be 4, which is exactly what our multipliers told us to do. And kind of using the first example as well. Remember, you don't have to do the first two. You can just find any consecutive numbers. So if I'm going to go from term 3 to 4 here, that fourth term divided by the third term, right? 24 over 12 is 2, which exactly is what our multiplier was. So if you can't identify it, no big deal, right? There is a mathematical approach to kind of do this. Because maybe we get down to a little bit harder examples here. We should notice that the numbers are headed down. The numbers are getting smaller, right? We go from term 1 to term 2. 20 is smaller than 40. Well, we're looking for a ratio, so we need a multiplier. Okay, maybe you can kind of see that, well, it's being cut in half. You know, half is being multiplied by, dividing by 2 is the same thing as multiplying, by 1/2. Think in terms of multiplication. Don't think in terms of division. Don't see this and say divided by 2. You need to be thinking in terms of multiplying by half. But you know, our kind of mathematical approach here, if we're finding that common ratio, let's just call it R. Again, I'm going to use that second number I know, so 20, and I'm going to divide it by the first number I know. Okay, so 20 over 40. And again, definitely use your calculator here. I told you that Calculate 84 is a great app. You know, it's the same exact graphing calculator that we see here, so I'm going to put that in my calculator. Right, so 20 over 40. Okay, 0.5. You can use this decimal. We've talked about this before in class. You know, what it means to be a good decimal and not a good decimal. So this decimal stops. You know, it's at 0.5. So we can use it, but get used to using the fraction. So remember the math button over here, math, enter. It's going to turn that decimal into a nice looking fraction for us there. Okay, so this simplifies out to be 1/2. So the multiplier here, okay, getting from one number to the next, it looks like we're multiplying by 1/2. Multiplying by 1/2. So if I multiply 10 by 1/2, it should be 5. And then the same thing here, 5 times 1/2. Again, referring back to your calculator, 5 times 1/2, we're going to say math, enter. Simplify your fractions, should be 5 over 2. All right, so we got 2 more examples here. Let's see how we can kind of keep going here. So again, if you can see it, awesome, great. You know, use that common ratio and get to the next number, but sometimes it does get a little bit tricky to see. You know, we see a lot of, these are big numbers, there's a lot of zeros. You know, go ahead, you know, use that little ratio thing that I've been showing you, okay? So we're going to take that second number, divided by the first number. Again, definitely refer back to your calculator. So I have 200 over 1,000. 200 over 1,000. Again, you know, we get that decimal. That 0.2 is a nice decimal for you, but I don't know. I think you're just going to be a lot safer. You can't screw up with the fractions. Sometimes the decimal gets a little tricky. So always refer back to the fraction. So this is 1/5. So it looks like we're cutting these numbers in fifths. So our multiplier is 1 over 5. So I'm going to use that same rate to go from 40 to 1 multiplied by 1/5. Well, 40 times 1/5. Let's see a calculator there. It's going to take us to 8. So it looks like that's the next number. And if I do that same 8 and I multiply by the 1/5, it's going to give me a decimal. But again, you know, decimal, you can use it, but just get used to using the fraction. It looks like it'd be 8/5. All right, and our last example here. So this one, you know, this one's going to be almost impossible for you to eyeball unless you can kind of get super close and guess and check. Use the kind of math that I've been showing you, right? So again, that second number I see, I'm going to divide it by the first number that I see. So 4.8 over 4. Well, 4.8 over 4, it looks like it is 1.2. So that 1.2 is my common ratio. That is how we're getting from one number to the next. Right? If I do 4 times 1.2, it takes me here. 1.2 is going to take me to the next one. Continue that pattern. So I'm going to see the 5.76 multiplied by 1.2. 6.912 would be the next number in the sequence. And I know I'm using the decimal. I just told you about the decimals. But the sequence has decimals. You know, you pretty much try to say true to the form of what the sequence is. So if the sequence was using fractions, you should use fractions. But in this particular case, it's using decimals, so I'm just going to use the decimals. So that's 6.912. I'm going to multiply it by the 1.2 again, and 8.2944. So when we throw in some multiplication, it definitely gets a little bit trickier and it gets a little bit weirder as we see. But, you know, you're only looking for two kind of patterns here. Is it adding or subtracting, right? Adding and subtracting refers back to your arithmetic sequence, or are we multiplying or multiplying by a fraction, right? And that's going to refer to as your geometric sequence, okay? So hopefully these examples help you.